Enjoy the journey of learning with Anil Kumar. I am Anil Kumar. Welcome to our trigonometric series where we are discussing some very difficult, challenging questions. One of them is how do we derive Mollweides formula for any triangle ABC? Now, based on this formula, you can get very good questions in any competitive exam. So, it is very important to understand all the concepts behind deriving this formula. We need to prove that a minus b over c equals to sine of a minus b over 2 divided by cos of c by 2, where ABCs are the three angles in a triangle and lowercase abc's are their corresponding sides. So let's first get some concepts clear. So I'll sketch the triangle of our reference. Let's say that is the triangle, labeling it as ABC. Means that the opposite sides will be lowercase abc. Now, in any triangle, we have a couple of things known to us. What is angle A plus angle B plus angle C? It is 180 degrees for sure, right? So, you can always write any angle in terms of the other angles, right? So, for example, angle C can be written as 180 minus A plus B, right? I mean angle A. So when we write normally in trigonometry, when we write A or B, it means the angle. So that is one thing which we kind of know. Now in a triangle, we can also use sine law. So sine law is that sine of A over A equals to sine B over B equals to sine C over C, right? Which basically is a constant, right? It's like a proportional equation which you have. So you can write ABC in terms of sine A, sine B, sine C. So basically A is proportional to, so we just cross multiply. So it's a sine A over the constant K. Right? B equals to sine B over K and C equals to sine C over K. So this part can replace A minus B over C, as you can see. Now we also have sine A minus B over 2 type of things. Where do we get that from? So that is from our sum to product formula, which I can again derive here. So let's do that also. You know what is sine A plus B? Sine A plus B is sine A cos B plus cos A sine B. And sine A minus B is sine A cos B minus cos A sine B. Correct. Now, in this particular formula, what is sine A minus B plus, if we add them up, what do we get? Right? So, if we add them up, we get 2 sine A cos B, right? Now, if I subtract them up, in that case, what do we get? So, if I do subtraction of one from the other, that is to say, sine of A plus B minus sine of a minus b. So when you subtract, these terms cancel and we get 2 cos a sin b. Perfect. So that's what we get, as you know. Now here, I'll do a small substitution saying that if I replace a with alpha plus beta by 2, similarly if b with alpha minus beta by 2. So if I do that, then a plus b will be only alpha, right? So if I do that, I get sine alpha minus sine beta equals to, let me write down equals to because we need more space, 2 times cos of a is alpha plus beta by 2 times sine of alpha minus beta by. You see that? So we have written the difference of signs in terms of the product of cosine and sine. All this will be utilized in deriving. Now, I hope you're well equipped with the formulas to go ahead. You can also pause the video and do the derivation. Here is how we are going to do it. First thing first, we are going to begin with the left hand side, which is a minus b by c. A can be written using sine law as sine of capital A over constant minus sine of capital B over constant, and the denominator being sine of capital C over constant. K cancels, we get sine of A minus sine B over sine C. Now we'll apply the difference formula, right? So we get 2 times cos of A plus B by 2 times sine of A minus B by 2, correct? Divide by sine 2 theta formula, we get 2 times sine of C by 2 times cos of C by 2, right? You know sine 2 theta formula. Let me write that also. Is basically 2 sine theta cos theta. Perfect. Now, since we need cos of C by 2, but we don't need sine of C by 2, we can always cancel 2's. We'll go ahead with the numerator as such, which is cos of A plus B by 2 times sine of A minus B by 2. And in the denominator, sine C by 2 can be written as sine of 180 minus A plus B, right, by 2 times cos C by 2. So in the numerator, we have cos of A plus B by 2 times sine of A minus B by 2 divided by, now that is 90 minus A plus B by 2. So it comes to cos of A plus B by 2, correct? And cos of C by 2. So clearly, cos A plus B by 2 cancel. And what are we left with? We are left with what we wanted, which is sine of A minus B by 2 over cos of C by 2. Perfect. So that is how we are going to derive this formula. I hope the concept is absolutely clear. Challenge series. In this video, we will take up derivation of Mollweides formula for any triangle ABC. The formula is given as a plus b over c equals to cos of a minus b over 2 divided by sine c over 2. Here a, b, c are the vertices of a triangle and lowercase abc are the relative sides. Let's try to understand some basic before getting into the derivation of this formula, which will require many combinations, right? So let's begin with the simple triangle itself. Let's say we have a triangle ABC. So what is this if I write ABC like this? In that case, the sides will be lowercase ABC as shown here. So opposite side is named as lowercase of the vertex. Now in this triangle, you also note one particular thing, that is the angles. If you add them up, so angle A plus angle B plus angle C is 180 degrees. So that's also important to understand, right? So angle A plus angle B can be written as 180 minus angle C. Make sense? This is also important since we are going to use it in our derivation. The other formula which is very popular is the sine law. Sine law states that sine of angle A over lowercase a equals to sine of B over B equals to sine of C over C, right? So basically it is a constant. So we can write this as a constant, and from here we can also get the values of A, B and C in terms of sine. That's what it is. If you look at the formula, it is A plus B over C in terms of sine and cosine, right? So from this formula, you can cross multiply and get the value of ABC. So A will be equal to, when you cross multiply, K comes in the denominator, sine A over K. B will be sine B over K. And C will be sine C over K. Perfect. So as you can see, we can write A plus B plus C in terms of sine. Now, once you do that, we'll end up with A plus B formula, right? So let me also share with you A plus B formula. Let us do it on the next page. Okay. So recall, let's say, so what is sine A plus B equals to? Sine A plus B is sine A cos B plus cos A sine B. And sine of A minus B is sine A cos B minus cos A sine B, right? Now, if we add them up, in that case, what do we get? We actually get sine of A plus B plus sine of A minus B equals to, these terms cancel when you add, and so you get 2 sine A cos B. Correct? Now here is a small substitution which will uh, help us get our formula. So if I write A equals to, let's say, alpha plus beta by 2 and B as equal to alpha minus beta by 2, right? In that case, what is A plus B? So A plus B, when you add them up, you get 2 alpha by 2, basically alpha, right? And similarly, A minus B will be equal to beta, right? You see that? So from here, we actually can replace, A plus B with alpha. So we can say sine of alpha plus sine of beta equals to 2 times sine of A, which is alpha plus beta by 2, and cos of alpha minus beta by 2. Makes sense. So you see what we have converted sine A plus B sine A minus B formula into sum to product formula. So this is also a standard formula which is called sum to product. As you can see, sine alpha plus sine beta, which is sum of these two, is the product of 2 sine alpha plus beta divided by 2 times cos alpha minus beta by 2. Very useful formula to solve trigonometric equations, because now once you get sum to product, you can actually take common factors and do many things. Perfect. So I guess all these formulas are absolutely clear to you, and now we are ready to share with you the solution, right? Okay. So as we said, A could be written as sine of A over K, some constant, right? So let's rewrite this equation. We will write this as sine of, let's write like this, A plus B over C, right, will be equal to sine A by some constant plus sine B by some constant over sine C over some constant, correct? So these constants, they cancel away, just multiply by K in the numerator and denominator, which gives us sine of A plus sine B over sine C, correct? So we got to this stage, we just wrote A plus B over C as sine A plus sine B over C, correct? And now in the numerator, we see A sine A plus sine B. So we can do sine alpha plus sine beta using the sum to product formula, right? Remember that? So we can actually rewrite this. So we are going to rewrite this as sine of, that was 2. So this time it will be multiplied by 2 times when you add the 2 sine A plus B by 2 cos A minus B by 2, right? So we get 2 sine A plus B by 2 cos A minus B by 2. Clear? Divided by sine C. So sine C can be actually directly written as 2 sine A cos B. You remember that? Half angle formula. So we can write sine C as 2 sine C by 2 times cos C by 2. Makes sense, right? So that is the double angle formula for sine. We know sine 2 theta is 2 sine theta cos theta. So we apply that formula right here. Now you see, what is sine? Sine C by 2, we are interested in figuring out. So it's a right triangle. So C is 180 minus A plus B, right? So we'll extend that part. C is 180 minus A plus B. So if we have cos C by 2 and sin C by 2 right there, we can write this as because we want sine c by 2 in the numerator, but we do not want sine a plus b by 2. You get the whole idea, right? So when I do c by 2, we will divide everything by 2, right? So c by 2 is equals to 90 minus a plus b by 2. Is that clear to you? Right? Now we have this expression which is cos of c by 2 here, which we don't want since we need sine of c by 2, which is already there. So we have to remove cos c by 2. Now here you see what is cos of 90 minus theta. Cos of 90 minus theta is sine theta. Perfect. So we are going to use these two concepts to get our final result. Look here. So in the numerator we have 2 sine of a plus b by 2 times cos of a minus b by 2. In the denominator we retain 2 sine c by 2 since we need it, but replace cos c by 2 as sine of theta. Theta basically is a plus b by 2. You see that point, right? So we will write this as sine of a plus b by 2. Is that clear to you? Perfect. So now from here, you can cancel sine of a plus b by 2 and also the number 2 in both numerator and denominator to get your result right, which is cos of a minus b by 2 over sine of c by 2. You get the whole idea, right? So that is how we derive this particular formula. I hope the steps are absolutely clear. Feel free to write your comment, share your views. If you like and subscribe to my videos, that'd be great. Thanks for your valuable time and all the best.